morning, all. Am I audible?
Yes, sir.
So, today we are going to study a new topic called arrays in C. So, we already studied about variables. So, what do you mean by variable? So, variable is a name given to a data item. So, in that variable, we can store some data items. So, listen carefully. Suppose I have a variable called int x. What's the meaning? I can store an integer value in that particular variable. Some memory will be allocated for x and some value will be stored in that memory location. Suppose I want to add two numbers, what will I do? I will declare three variables. First two variables to store data, and for the third variable to store the result. Okay, suppose I want to add 10 numbers or I want to store 10 numbers. What will I do? I will declare some variables, some int n1, n2, n3 up to n10. Then I will read each and every value and store in these variables. You just imagine I want to store some 100 values. It is possible by declaring 100 variables, but it is a bit difficult because first of all you have to declare 100 variables. Then I have to read all these values. So it is a bit difficult one. So to avoid these things, there is a concept called arrays in C. So array is a derived data type, fixed sequenced collection of elements of same data type. An array is a collection of individual data items that is ordered. That means one can count off the elements 0, 1, 2, 3, etc. Fixed in size, homogeneous. All elements have to be of same type, that is int, float, char, etc. In array, in C, each array has two fundamental properties, the data type and size. Individual array elements are identified by an integer index. In C, the index begins at 0 and it always returns inside square bracket. So earlier if I declare something called int a, that means some space will be allocated to store a single variable. So here array is a derived data type. Suppose I am declaring something like this. In the declaration we discuss in next slide. Now I am saying a bit int a of 10. Int a of 10 means here only one location is allocated or only space for one variable is allocated. Here some space for 10 variables are allocated. Some space for some 10 variables are allocated. Here both are A. Here A refers to array which is of size 10 and that array can hold integer values. So just imagine like it will have some 10 cells and each cells we can store an integer value. And the entire thing we call it as A. So if you remember the definition for identifier, there we studied identifier is the name given to variables, functions and arrays. So we already studied variables, we already studied functions. Now we are going to discuss about arrays. So A is a name given to array of 10 elements each of type integer, each of type integer. So fixed size sequenced collection of elements of same data type. So here the size means 10. We can store 10 integers. So that's the meaning of fixed size. Sequenced means it is stored in nearby memory locations. In nearby locations only we are going to store each and every cells. And each and every cell is of same data type. So if we declare something like this, we can only store integer in each and every cells. So we can't store integer in one cell, in the next cell we can't store character, in another cell I can't store floating point number. But here in each and every cell I can store only same data type. So next some properties are there. Ordered. Some ordering is there. So this refers 0, this refers 1, 2. That means first cell is numbered using or identified using a value 0. Second cell is 1. Third cell is 2. And also some ordering is there. Fixed in size, we already discussed. Here in this cell I can store only 10 data values. Homogeneous means all elements have to be of same type. That is also we already discussed. If we declare integer array, we can store only integer in those locations. Here the size is 10, so I can store 10 integer values. That means I can store a maximum of 10 integer values. In C, each array has two fundamental properties, data type and size. So in this example, A is an array whose data type is integer, this is data type, and size is 10. This is size. Size is 10. So every array there will be two properties, size and data type. Individual array elements are identified by using an array index. So here I have 10 cells. You just imagine the first cell I have stored 5, second cell I have stored 10, third cell I have stored 12. So okay. So individual array elements are identified by an integer index. In C, the index begins at 0 and is always written inside square bracket. So here I have an array called mark, where I stored marks of 10 students, 20, 15, 12, 10, 11, 6, 18, 16, 15 and 40. So this entire array is called mark. The entire array can be called as mark. And size of array is 10 because I want to store marks of 10 students. So each and so that means in this array I will have some 10 cells. So these are called index value. First cell is numbered using 0. Second cell is numbered using 1. Third is 2. Suppose I want to access the mark of 6th student. Sixth student means index value 5. First student means index value is 0. So by using this thing, we can access the value. Access means either we can read the value or write the value in the location. So mark of 5 denotes, you just remember this one, within square bracket, we have to write that index value. That means it refers to the value 6. In C, index value begins at 0. And it is always written inside square bracket. Square bracket means this one, box bracket. And index value is always written in square bracket. So this is the introduction to array. Any doubt in any points? If it is clear to everyone, please type clear in the chat box. Any doubt in arrays? You can type, if you have any doubt, you can type doubt also in the chat box. Okay. We move to next slide. So here I am going to discuss about one-dimensional array. So the earlier example is also an example for one-dimensional array. There are several forms an array used in C: one-dimensional or single-dimensional and multi-dimensional array. Anyway, in our syllabus we have to study one-dimensional. We have to study one-dimensional and single-dimensional. First one is declaring one-dimensional array. So we all know how to declare an integer. Suppose int x. This is how we declare an integer. So similar to that, while declaring an array, what you have to do is int some array A. If I want to store some 100 elements, you just put a square bracket, write 100 and put a semicolon. The meaning of this statement is A is an array, its size is 100, that means we can store 100 values, and here I have an integer, that means each is of type integer. Each cell can store an integer. Similarly, I have 100 cells. So the syntax is data type. So data type followed by array name. Here array name is A, followed by array size. Here size is 100. So here these are some valid array declarations. Int mark 100, that means it can hold 10 integer values. It is not mark 100, it is mark 10, and it can store 10 integer values. Here char x of 50, that means x is a character array which can hold 50 characters. Then float avg 15. Avg is a floating point array which can store 15 numbers, 15 fractional data, or 15 numbers which will contain some fractional numbers. Since the array is one-dimensional, there will be a single subscript or index. We already discussed about subscript or index, whose value refers to the individual array element which ranges from 0 to n minus 1. So the same example what we have explained earlier. Here I have an array called mark which can hold 10 marks for 10 students. And if you notice the index value, it starts from 0 and it ends at 9. Suppose if I have an array which contains n elements, the index value always starts from 0 and ends at n minus 1. Ranges from 0 to n minus 1, where n is the total number of elements in the array. So if the index value is 0 to n minus 1, then the array will contain n elements. So one more important thing, you just listen carefully. Suppose I am declaring int m of 10. Okay, leave it. Okay, you just look at this example. Int mark of 10. And you just look at this term. Here I have a data type, then the array name, then the size. Here this 10 refers size of the array. Here this 10 refers size of the array. So in array declaration, the value within that box bracket or square bracket refers to size of the array. While declaration, the value within that square bracket refers to size of the array. So here I am just writing mark of 5. Here there is int also. Here mark of 5 refers the cell with index value 5. The cell with index value 5. That means it refers to this address location or this memory location. So both are different. Here mark of 10 means Mark is an array whose size is 10. Here mark of 5 is 5 refers to the index value of array mark. So here there is an integer, here there is no integer. So in declaration, the thing within square bracket is size. While we write something like mark of 5, this 5 refers to index value. So last point and important point, space of arrays is allocated in contiguous memory locations in primary memory. So when we declare a variable, I already told you some space will be allocated in primary memory. Here I am declaring array. That means some space will be allocated in memory. So always it will be allocated in contiguous memory location. Contiguous means continuous memory locations or nearby memory locations. So when the space for array is allocated, some it will be in contiguous memory location or in the nearby memory locations. So suppose our system takes 2 bytes to store an integer. 2 bytes. Suppose my computer takes 2 bytes to store a integer. Adidev,
Yes, sir.
suppose an integer variable take 2 bytes. If I declare an array of size 10, how many bytes will be allocated?
10 bytes, sir.
10 bytes will be allocated. Okay. 10 bytes or I am making an array of 10, size 10. How many bytes?
Array of 10 ഉണ്ടാക്കുമ്പം 10 bytes allocate ചെയ്യും.
So I am declaring an integer array. So here a single integer variable takes 2 bytes.
Okay, okay, അപ്പം 20.
Okay, 20 bytes will be allocated. Okay, you can mute the mic. So here I have a diagram. This is actually part of a memory. Just think like a part of a RAM. And here I have some address values. Here I have some address values. So integer takes 2 bytes. So 1001 refers to 1 byte. 1002 refers to second byte. So to store an integer, I need 2 bytes. So this 1001 and 1002 is used to store 2 bytes, or here we can store a integer. We can store a single integer or one integer in 2 memory location. We allocate it together to store one value. So here you just imagine this is the mark array and this is the memory allocated. So in the first 2 memory location, what will be stored? This 20 will be stored. Here that 20 will be stored. Then next 2 memory location is to store the next cell. The value in the next cell is 15. So here 15 will be stored. So this is how memory is allocated for array. So do remember this concept, do understand this concept properly. Later we have to study on concept called pointers and array. There it will be useful. So try to understand it properly. So I'm just assuming that 2 bytes are taken to store on integer. So here from 1001 to 1020, the memory is allocated for array mark. So in that 1001 and 1002 refers to 0th index value. Similarly, in the 9th index value or the last index value, the memory locations allocated are 1019 and 1020. In that, the value 14 will be stored. In that value 14 will be stored. Is it clear? If you have any doubt, please ask. Anyway, today's attendance is bit low also. Anybody have any doubt, please ask. Okay, thank you. Initialization of one-dimensional array. Okay, we already studied initialization is of two types, at compile time and at runtime. Compile time means during the time of compilation or during the time of translation itself, we know the values of the variable. So if I declare something called int x and also declaring something like int a equal to 10 in a program, suppose I am compiling it or I am translating it to machine level language. So at that time I didn't know the value of x, but I know the value of a. I know the value of a because a is initialized with a. Sorry, a is initialized with 10. A is initialized with 10. So this is called compile time initialization. So during the translation itself, the variable knows its value. Some value will be stored in that variable. Here x will not contain any value. X will contain some value, but it is not predictable. It will contain some garbage value. So this is called compile time initialization. So similarly, we can initialize arrays also. In compile time, we can declare arrays also. 1 minute. Okay, the syntax is data type, array name, array size, list of values. So earlier to declare one variable, we have int, that is data type, variable name, then I have equal to, then the value. Here data type is there, array name, then size of the array. So here I have some examples. Int number of 3 is 1, 2, 3. So here we know the size of the array is 3. In the first cell 1 will be stored, the second cell 2 will be stored, and the third cell 3 will be stored. And these are the index values. We all know the first cell have index value 0, second cell will have the index value 1, and third have the index value 2. So just listen this example. Here it is a float array whose size is 5, but the list of values contain only 3 elements. The list of values will contain 3 elements. And that what happens is, first cell will contain 1.2, second cell will contain 3.1, third cell will contain 5.6. But since the size of array is 5, remaining 2 cells will be there. Those remaining 2 cells, the value 0 will be stored. So remaining values will be set to 0 automatically. So if we declare an array of size 5 and if we are only initializing some 3 values, 2 values will not have any initial values, but it is set with 0. Similar to that, I have a character array. Always remember, when we initialize character array, the characters must be already studied. Character constants or any single character which has to be written within single quotes. So we have to write everything in the single quotes. So this one is very important. Here the array name is counter. Here I didn't mention any size. Didn't mention any size. But there is some list of values. Here in the list I have 4 values. I have 4 values. So here the array name is counter. So since it contains 4 values, the array size also becomes 4. The array size also becomes 4. So these are examples of compile time initialization. These are examples for compile time initialization. Is it clear? Okay. So next we will study runtime initialization. This is not compile time, this is runtime. An array can be explicitly initialized at runtime. That means explicitly means from outside. So here I have an example program. Write a C program to read and display marks stored by students in a subject. Write a C program to read and display marks scored by students in a subject. So with this example, I will explain the concept of runtime initialization. So here I am going to read and print array. So I'm using some read print array dot c. Okay. Main program execution starts at main. So listen carefully. So here I have to read the marks of some students and store it in an array, and I have to display those contents. So before reading the marks, I have to know the number of students. In your class, you have 38 students. In some other class, it may contain some 50 students. In some other class, it may contain some 24 students. So suppose I want to use the same software or the same program for all these three classes. So first class contains 24. Second is your class which contains 38. Some other class will contain 45. So here size of array is 24. Here the required size of array is 24. Here required size of array is 38. Here it is 45. So this array size is varying. So generally in C program what we do is we will declare a larger array. We will declare a bit larger array. Suppose I am declaring something like int mark 100. So that means this array can hold marks of 100 students. It can store 100 students. But when we execute the program for first class, 100 student means some 100 cells will be there. When we execute this program for the first class, we will use only the first 24 cells. Then when we execute this program for your class, it will take only the first 38 cells. So when we execute for a class which has some 45 students, it will make use of only first 45 cells. Suppose in some other case, some 60 students will be there. There also this program will work. In some other case, sometimes some 150 students will be there. In that case, we can't use this program. So always remember, you have to declare a larger array size. You have to declare a larger array size. So I am declaring some, int mark of 100. Advait,
Yes, sir.
what is the meaning of this statement int mark of 100? What are the things you
Create
understood from this statement?
create an array.
Okay, create an array.
To
What is its name? What
mark
is the mark? What is the type of that array?
integer
Integer. How many cells will be there?
99.
Not 99. 100 cells will be there. But there is no 99 cells. There is exactly 100 cells. The first cell is numbered with 0. That means last cell will get a number 99, or the first cell is get an index value 0. So that means last cell will get the index value 99. Okay. So here some space to store 100 integers will be allocated. That's the important thing. 100 integers will be allocated. Okay. So one more thing. Here I told you the values are 0 to 99. 0 to 99. Okay. Next what I am going to do is printf enter number of students. So I already told you in the first class I have only 24. At that time the number of students is 24. So I have to read that input. In the second class I have only 38 students. So I have to read that input. So scanf percentage d, because I have only one integer, comma ampersand n. So I have to declare that variable also. So here we can declare comma n. Here comma n means n is a variable, but mark of 100 is an array. Okay. Suppose the n value is 24. Okay, suppose value of n is 24. Alex,
Yes, sir.
so n value means 24 means I can store marks of 24 students.
For students.
Okay,
Yes.
so what will be the index value of mark of first student?
0.
0. Okay, good. What will be the index value for the mark of second student?
1.
1. What about the third student?
2.
2. What about the last student? Alex?
23.
23. Okay, very good.
23, sir.
23. Okay, okay. So here I have some value 0, 1 up to 23. Okay. So here first I have to get the value 0. Next I have to get the value 1. Next I have to get the value 2. And in the end I have to get the value 23. Ankur Jaiswal. Ankur Jaiswal, can you hear me? Anu Fasmin.
Yes, sir.
So here I have some values 0, 1, 2 up to 23. That means 23 means here 23 means n, number of students. 0 to n. Sorry, here number of students is 24, 23 means n minus 1. 23 means n minus 1. So can you write a for loop for these values? How to write a for loop for these values? For
I is equal to 0.
I, okay, very good. I equals 0. Then
I less than 24.
I less than 24. In this case, the n value is 24. But here I have read n. So what will be it?
I less than n.
Okay, very good. I less than n. Semicolon, then
I plus plus.
I plus plus. Okay, very good. Okay. Next statement, you have to listen it carefully. And you can mute the mic. Scanf percentage d, comma, ampersand, mark of I. Mark of I. So I have used one more variable. So I have declared it I. Okay. So I already told you when n is 24, the loop will iterate for 0, 1, 2, 3 up to 23. So here I have something called mark of I. Initially I value will be 0. I value will be 0. So you just imagine I have an array. Zero, 1, 2, 3. Here actually it has some more cells, some 100 cells because it is declared as 100 here. So this is the name of the array is mark. So what is mark of 0? Mark of 0 refers to this cell. Mark of 0 refers to this cell. So earlier we studied some ampersand n. So in this n value, one minute. So n is 24. So earlier I have used only n. N means some space will be allocated for n, and in that space that value 24 will be stored. So here some 100 cells are already allocated. Here mark of I means this location. In that location, mark of first student will be stored. So a scanf statement will be executed. So the computer will wait for some input. So I will enter some value 10. Then it will execute I++. I++ means 1. Then it will test the condition. 1 is less than or equal to 24. 1 is less than 24. I less than 24 means it will iterate from 0 to 23. 1 is less than 24. That means this statement is again executed. Now the value of I is 1. So this mark of 1 refers to second cell. So user will enter some value. Just imagine he entered some value told. That will be stored in second cell. So similarly, we can store all these 23 values, all the 24 values. So remaining 76 cells will be there, and those cells will not contain any value because we are only making use of first 24 cells. First 24 cells, that means index value 0 to 23. Is it clear? Anybody have any doubt? Please ask. If it is clear, please type clear in the chat box. Okay, got only few responses. That means some people have some doubts. Mayankraj,
Yes, sir. I
is it
am
clear,
having
Mayank?
doubt. Sir, why means we can write mark n means in third line. Int mark n.
Int mark n.
Yes, sir.
Okay. So you're asking why I declared 100. So I
Yes,
already
sir.
told you in C program we have to make the declarations in the first statement. That means so first in C program the execution starts in the first statement. This third statement is the first statement. So always the declarations are made in the first statement. So at that time I didn't know the value of n. That's the rule in C program. Declarations must be made in initially. Before executing other steps, we have to make the declarations. So at the time of declaration, I didn't know the number of students. That's why I declared a larger array. But in some other programming languages like Java, we can declare these arrays later. That means we can declare this array after we read the size of the array. Or after we read the, here in this example, after we read the number of students, we can declare the array. So in that occasion, you can use some int mark of n. And also I think some of the advanced compilers or some modern compilers in C also supports that concept. But it will not work in all compilers. It will not work in all C compilers. That's why I follows this method. And in most of the textbooks also it is saying we have to declare anything before use at the initial steps in the program.
Yes,
Okay.
sir. Yes, sir.
Okay, let me try that one also in this compiler. So what he said is, here I have to declare something like int mark of n. So anyway, in this compiler it is working. So in the compilers like Turbo C++, it will not work. So anyway, we will follow the conventional method. Okay. Ranveer.
Yes, sir.
So I hope you understood how to read an array. Can you say how to print the elements in an array? Now I have some 24 values. So how to print those values?
So printf.
Okay. Okay, printf. Tell
Marks
Ranveer.
of the students.
Okay. Then
Semicolon.
so I have to print these values 10, 12, some 30, 20, 50, like that. So will this statement print those values? Ranveer,
Yes, sir.
you are saying that that will print, or it will definitely print. It will not print those values. Okay. Rishi Sagar.
Yes, sir.
So how to print the values in an array? So
Uh,
anyway, I have to print the first cell first, then second cell. How will you print? Can you have any idea?
mm, sir, printf marks of student, comma,
Okay.
uh, mark I bracket.
Okay, it is some partially correct, but I what will be the value of that I? So anyway, I have to get the values of I from 0 to some 23. So how I will get some values of 0 to 23? How I can get the values 0 to 23?
For loop.
Okay, you have to use a for loop. Okay, very good. Okay, anyway, I have to use one more for loop for I equal to 0. Same for loop, I less than n, I plus plus. Varsha Shibu.
Sir.
So after that, what will I write? What will be the ninth statement?
Print.
Okay, print or printf?
Print.
Okay, printf. Then within bracket, what will I write?
Mark of students.
Okay, mark of students. Let me check the output. Mark of students.
Comma n.
Comma. Okay, comma.
Comma. I.
I. You know something, but you didn't have the correct clarity. No problem. Okay, Varsha, suppose I want to print you, I asked you to print n. What will you write? Suppose I want to print the value of n. What will you write here?
Percentage D.
Okay, percentage
Comma.
d, comma
N.
comma n. Okay. So here the I values are iterating from 0 to 23. First I have to print mark. So what will I write here? First I have to print mark of 0. What I will write there?
Mark I.
Mark of I. Okay, very good. Okay, that's the answer. That's the correct way to print.
Excuse
So I am
me, sir.
giving, okay, please ask.
Sir, in 7th line, is
Okay.
percentage D will take the value of I.
No, percentage D will not take the value of I. Percentage D ampersand mark of I.
Oh, yes, sir, yes, sir.
So
Yes.
ampersand n means that location, that memory location. Mark of I means initially it will be mark of 0. That means the first cell.
Oh, yes, sir.
Okay. It will refers this first cell. Similarly here it will, here I will be 0. First value will be printed. So I give some space after percentage D. So I am writing one more statement. Here I have to write printf entered marks are. So now I will execute the program. So number of students I am not giving 24, I am giving only 5. So I have to enter 5 values, 10, 15, 12, 16, 8. So 5 values, press enter. So entered marks are 10, 15, 12, 16, 8. Okay, is it clear? So always remember how to read an array and how to print an array. How to read an array and how to print an array. In every array related programs, these two blocks will be there. To read the array and to display the array. In between we have to perform some actions. Sometimes we have to arrange these numbers in ascending order. So once you read, after converting it into ascending order, you have to print it. So definitely 2 for loops will be there. So any doubt in reading and printing array?
Sir, in line number 10,
Okay, line number 10. Okay.
slash and should also be used, sir, to get it
Slash
into new lines.
in which slash?
Line
Can
number
you
10 slash,
okay, slash. After slash,
slash
what do you
n.
had? Okay, slash and means it will print in the line by line. Okay, let me try that also. No problem. Slash n means each and every marks will be printed in new line. So I am just entering 3 marks, 3, 5, and 6. So it will be printed in the new line, 3, 5, 6, line by line. Yeah, in that way also you can write.
Yeah, yes.
Okay. So always remember this first for loop is to read. Second for loop is to display. Any doubt? If it is clear, please type clear in the chat box. Okay. Okay, next I am going to discuss about arrays and functions. So one more thing. This is how the array values are initialized during runtime. So during the execution only I have stored the values to array. So that is why it is called runtime initialization. Okay, next is arrays and functions. So it's an important topic. So I will try to explain with the help of an example. write a C program to read marks scored by students in a subject and display it using functions. So for displaying the values, we have to use a function. So array, print, read array, function. So listen carefully. Okay, these steps will read an array. We already discussed how to read an array. These steps 7 to 11 will help you to read an array. But here I have to display the array using a function. So for that I have to define an array. Here I am declaring it as void. Why I use void, that we will discuss later. Void display. Here I have an integer array. So you have to write an array declaration. Int x. No need to give the size. Important point. When we define functions for array, in the formal argument, no need to give the size. So by seeing itself, we know the first parameter is, or the first argument is an array because there is a square bracket or there is a box bracket. Since there is a box bracket, we know first parameter will be an array. Then comma int n, int size. I am declaring it as int s. So just write a for loop. For I equal to 0, I less than n, less than s, because in this function the variable used is s. I plus plus. Saget Kumar,
Yes, sir.
what will be the fourth statement in the program?
Printf.
Okay, printf.
Number of students, enter number of students.
So it is already written now. I have already read the values. I am only displaying those values. So what will be inside printf? Printf, here what I have to write is printf percentage d, comma,
In
comma, what will be written after that?
n, sir.
What you are saying? You just think about and say printf percentage d comma n means you are printing the value of n. What I am doing here is I have to display the elements in an array. Okay, anyway, I will explain it later. You can mute the mic. So here I have to write x of I. Here I have to call the function. For that, we all know how to call the function. Display function name within bracket arguments. Here mark, comma, n. So I will explain the working of the program. Here one more thing you have to remember is here I have written only mark. No need of square bracket here. Don't give any square bracket here. While function calling an array, while calling an array which deals some arrays, while calling some functions which deal some array, No need of using some square bracket in the function call. Adidev.
Yes, sir.
So here I have a function main. So what will be the first statement which is going to be executed in this program?
ഒരു അറേ 100 ഇത് ക്വാണ്ടിറ്റീസ് ഉള്ള ഒരു അറേ ഉണ്ടാവും പിന്നെ
Okay,
n
okay, okay,
മൈനസ് വാല്യൂസ് എല്ലാം
okay,
ഉണ്ട്.
okay, enough, okay. So the execution starts at line number 8. So first is int mark of 100. An array will be declared which can store some 100 values. 0 to 99 will be the index value. Then on value will be there, store n. And another space will be allocated for I. Enter number of students. Some message will be printed. Then scan of %d, ampersand n. At that time user will enter some value. You just imagine user entered from value 3. So n is 3. For I equal to 0, I less than n, I plus plus. So initially I value will be 0. 0 is less than 3. So this statement will be executed. So I is 0. So at mark of I, some value will be stored. Scanf statement is there. So user will enter some value. So that value will be stored here. Then I plus plus. I becomes 1. So in the second cell, some value will be stored. Again, I becomes 2. Some value will be stored. Next, I plus plus. I becomes 3. But 3 less than 3 is false. 3 less than 3 is false. So this loop will not execute anymore. Then there is a function call. Very important. Listen very carefully. Next, there is a function call. I am calling the function display. So the control will go here. The control will go here. So here the first parameter is mark. First parameter is mark. So just imagine these are the things for display. So here I have x. So this is very important. Listen carefully. Here I have x. Here x is an array because there is a square bracket. We didn't mention any space. We didn't mention any size here. We didn't mention any size here. So when we call this function, what happens is display mark comma n. So what is mark? Mark is actually this array. So mark is a name given to this array. Mark is the name given to this array. So when we make a function call, so this array actually getting another name also. This array actually getting another name also. That name is x. So what you have to understand here is, while executing this display function, the space for new array is not allocated. X is actually not a new array. Earlier I told you when we will come back to that point later. So there is no space for array will be created. So it is actually, so this there will be an earlier existing array whose name is mark. That array will get a new name also. When I make a function call for array, it will get a new name also. That name is x. So the meaning is this mark also refers to this array. Similarly, this x also refers to the same array. This array now got two names, mark and x. So those two, mark and x, refers to same array. Mark and x refers to same array. So here I have another variable int s. So but since it is an integer variable, some space will be allocated for s. Some space will be allocated for s. Here n value will be stored in s. This value 3 will be copied to s. This value 3 will be copied to s. So while functions, this array and variables executes in a different form. Here actually there is a copy of a variable, copy of this value. This 3, the value of 3 is copied here. So the value of n is copied to s. The value of n is copied to s. Here this array is not copied to x. The array, there is no array created, there is no array new array created, and those arrays are not copied to that array. Here the in variable, the value is copied to that variable. N is copied to x, n is copied to s, n is copied to s. But here mark is not copied to x. It only give a name, new name to this array. Already there is an array in main. This is referring to main. This is referring to display. So this x and mark refers to same array. So now inside that I have a for loop. For I equal to 0, I less than s, because here in this function I know only s. S is also 3. So it will execute for 0, 1 and 2, and values x of 0 will be printed. What is x of 0? Same 3. Because the name of the array got a new name called x. So next x of 2, 1 will be printed. X of 1 means 4 will be printed. X means same array. Then x of 3 will be printed. Sorry, x of 2 will be printed. That is 6. That is also same array. It also refers to same array. So understand this concept very clearly. So when we pass an array to the function, actually the entire array is not copied to that function. That array will get a new name, and that means the arrays in main and display are same. Here the variables in n, main and display are not same. N is a different variable, s is a different variable. These values are copying. Here there is no copy operations are happening. Any doubt, any confusions, please ask. If the concept is clear, please type clear in the chat box. Okay. Do you have any Onam celebrations today? Please respond.
Yes, sir, at 11 o'clock.
At 11 o'clock or 9 o'clock?
I think it's 10
11.
11, okay, okay. So we will discuss one more program and we will wind up today's session. So next we have to study searching operation. So searching is of two types, linear search and binary search. Today we will study linear search. So searching is a very simple operation. I have an array of elements. And I am searching whether a given element is in array or not. So I have an array of elements. I have to search whether that array contains that element or not. That is linear search. 2, 3, 5, 1, 7, 6. So this is an array. Suppose I am searching 5. The end result is 5 is found. We are searching for something among these elements. We are searching for 5. If I found 5, we can say that element is found. Suppose I am giving 4. This element is not in array. That means the searching is, after searching I will say 4 is not found. So that is searching. So linear search is a very simple procedure. So linear search is a very simple search algorithm. In this type of search, a sequential search is made over all elements one by one. Each item is checked, and if a match is found, then that particular item is returned. Otherwise, the search continues till the end of the data collection. So here I have an array 10, 14, 19, 26, 27, 31, 33, 35, 42 and 44. So from the animation itself, I hope you understood linear search. So I have to search 33. First this 33 is matched with 10. It is not same. So it will go and search in the next position. 33 and 14 will be compared. It is not same. Then it is compared in 19. It is not matched. Then it is compared with 26, not matched. So it will move forward. It will compared with 27, not matched. So it will move forward. It will match. It will compare with 31. It is not matched. Then it will move forward. Now 33 and 33 is matched. That means the searching is successful. That means the searching is successful. So any doubt in linear search? Any doubt in linear search? Shashikant? Shashikant,
Yes, sir.
can you summarize linear search? Did you understand linear search?
Yes, sir.
Okay, can you summarize it?
Yes, sir. Of course. It is mainly it is very simple and it means mm, if we if we if we have given
Okay,
a
okay.
value,
Okay,
we
if you
start.
understand it, no problem. Okay, then we will go to the example program. So linear search dot C. So here three inputs are there. Not three inputs are there. First one is n. That means number of elements. Then some elements. Then some elements. Some 3, 2, 4, 1 and 5. So first is number of elements. Next is elements. Next is element. Element to be searched. ES. Just call it as ES. Element to be searched. Element to be searched. Okay. Listen carefully. Main. Varada, we are.
Yes, sir.
How to declare an array?
Array declare int
Int. Okay.
int
You can give any name. No problem.
number
Okay. I am giving A. Okay. Then.
square bracket size.
Okay. Square bracket. Inside that I have to give some size. So here I am giving only 50. Okay. Then I am declaring one more variable n to read number of elements. One more variable es to read element to be searched. Okay. So printf enter number of elements. Scanf percentage D, comma, ampersand N. Tanush J.
Yes, sir.
So what will be the next statement?
For loop on
Okay, for loop. Very good. For.
I is equal to 0.
Okay, equal 0.
I is less than n.
I less than N. Okay, then
I plus plus.
I plus plus. Then what will we write?
Scanf
Okay, scanf. Then,
percentage D.
okay, percentage D. Then,
Ampersand
comma, ampersand
A
A
bracket line.
bracket line. Okay, very good. Same thing. A for loop to read the content of the array. Okay. Next, one more message I have to print. Printf. Enter element to be searched. Scanf, I have to store it in ES. Percentage D, comma, ampersand ES. Okay. So you already saw the example of this linear search. So here we are comparing. Okay, just imagine I have entered to be searched as elements to be searched as 1. First it will compare with 3, then it will compare with 2, then it will compare with 4. Otherwise I can say 1 is compared with 0th location, 1 is compared with first location, 1 is compared with second location, 1 is compared with third location, and I have found a match. So here 0, 1, 2, 3. I have to compare with 0th location. I have to compare with 1th location. I have to compare with, first location. I have to compare with second location. I have to compare with third location. So I have to perform some repeated action. So again, I am using a for loop. For. So maximum thing is I have to search it from 0 to, here 5 elements are there, so 0 to 4. So same for loop. I equals 0. I less than n. I plus plus. So here I am writing a if condition. If a of I equal to ES. I am comparing whether the first cell is same as ES. Then printf element found. So once the element is found, no need of searching in the remaining part. So if I search for 3 instead of 1, so in the first cell itself I will get a match. In the first cell I will get a match. So no need to continue for the remaining part. No need to continue the remaining iteration. So I have to come out of the loop. So to come out of the loop, which statement I can use? Rohit PB. Rohit PB. Rahul Bharadwaj.
Yes, sir.
So Rahul, to come out of the for loop or to stop the execution of the for loop, which statement I have to use? Rahul, I am asking to you.
Return, sir. Hello.
Not return. Return is to function. Is used in function. I am saying to come out of the loop.
Break, sir.
Yeah, you can use break. So no need to continuing it.
Okay, sir.
Break. So element found I have printed. There is no problem in that. So where I will write element not found. Suppose I am searching 6 in the array. Suppose I am searching 6 in this array. Suppose I am searching 6 in this array. The result will be element not found. So where I can write that element not found. Deepak,
Yes, sir.
where I can write element not found.
Element nodes found.
Yeah.
എങ്ങനെ അത് ഇതാവാൻ നിൽക്കുമ്പോൾ എല്ലാതും സെർച്ച് ചെയ്ത് കഴിഞ്ഞിട്ട് അതിന് ഈക്വൽ ആയിട്ടുള്ള ആ വാല്യൂ കാണാൻ നിൽക്കുമ്പോൾ
So how to write it programmatically in the program where I will write.
അത് ഈ എൽസ് എടുത്തിട്ട്
Okay, you are saying writing else. No problem. Your thought process is very correct. Else element. It is not exactly correct. Element not found. So I'm executing the program. So I is not declared. So I'm giving only 5 values. So I'm entering 5, 6, 3, 1, and 8. An element to be searched. I'm entering 9. My expected output is element not found. So I got the output element not found, element not found, element not found. But it is printing multiple times. It is printing multiple times. It is printing multiple times. Why? Because first this 9 is compared with 5. If a of 0 is equal to es, that is 9. This condition is false, so it will print element not found. Next it was compared with 6. Again this condition is false. At that time also element not found will be printed. So similarly, the element not found will be printed for each and every values. So to avoid this, we can use the flag concept. So in prime numbers, we use the flag concept. So first of all, we have to make an assumption. Here I am making an assumption that element is not in the array. Element is not in the array. Here my assumption is element is not in the array. So at some point, if this condition is true, what's the meaning? My assumption is wrong. My assumption is wrong. So here I can write, so I can change the flag value to 1, f equal to 1. So initially I assumed the element will not be there in the array. So but later at some point I found the element is in the array. At that time my assumption is wrong. So I have to change the flag value to 1. I have to change the flag value to 1. So here you can write after for loop. So if the flag value is 0, even after the searching means element is not found. If the flag value is 0, even after performing this much operation, that means this condition is always false. In that particular case, the condition is always false. So here you can write if f equal to 0, you can write element not found. So if you remember the concept in prime numbers, it will be very easy to understand. So I'm executing the program. Some 4 elements I'm entering. 1, 8, 9, 5. I'm entering some value 10. So element not found is executed. Acknell Jose.
Yes, sir.
Acknell Jose, so is it clear, Acknell?
Yes, sir. Yes, sir.
Okay. So anybody have any doubt? If you have any doubt, please type in the chat box. Otherwise, type clear in the chat box.
Sir,
Okay, ask.
can we
Uh,
write in 19th line if in 19th line, sir?
okay, 19th line. Okay, if
Uh, can we not use the flag concept and directly write as a of means a square bracket I not equal to es?
19, how can you write if a of I not equal to yes? At that time, what
No,
will be the value of
no, sir,
what
no,
will
sir.
be
It
the
is out of the loop. It is out of the loop.
okay, okay. So the
Understood,
I
sir.
value
Understood.
I value didn't have any relevance there if I write it that.
Yes, sir. Yes.
Okay. So here in some other way also I can write. Instead of this line here I can write else printf element found. I think this is the logic I have used in prime numbers. So if the element is found, I am changing the flag and I am exiting from the for loop. If f equal to 0, f equal to 0 means my assumption is correct. If my assumption is correct, in a particular case, I can print element not found. Else means my assumption is wrong. When the assumption is wrong, what happens? The flag value is changing to 1. That means it is not equal to 0. At that time, this else will be printed, element not found. In this way also, we can implement linear search. So is it clear?
Yes, sir.
Okay. Any doubts you can ask, otherwise we can wind up.
സർ
Okay.
സർ
ചോദിച്ചോ.
ഇതല്ല ഇതിന് മുന്നേ ചെയ്ത അറേൻ ഫങ്ഷൻസ് ഇല്ലേ
ഓക്കെ ഓക്കെ എടുക്കാം. one minute.
ഡിസ്പ്ലേ ചെയ്ത അതൊന്ന് റൺ ചെയ്യൂ.
Okay. I think it didn't run it now. Some error is there because I didn't declare I. Okay, I had to declare I here. Again, some error is there. I didn't put semicolon. Number of students I am giving some 4. It's actually one more statement I required. So anyway, I'm printing some values. 4 values. Now it is printed. Who asked that doubt? Who asked to run that program? ആരാ ചോദിച്ചാരാ? പേരെങ്ങനെയാ?
ഋഷി.
Okay, Rishi. Is it clear?
ആ ഓക്കെ സർ, കുഴപ്പമില്ല.
എന്താ കൺഫ്യൂഷൻ എന്താ അത് പറയൂ. ഋഷി സാഗർ.
ഇല്ല, കൺഫ്യൂഷൻ ഒന്നുമില്ല. നമ്മള് ഇത് നേരത്തെ ചെയ്യുന്നതിൽ വലിയ വ്യത്യാസമൊന്നും ഉണ്ടോ?
There is no difference, but in
ഫസ്റ്റ്
the
പ്രോഗ്രാം ഈ പ്രോഗ്രാം തമ്മിൽ
the purpose is same, but the implementation is different. First program I didn't use any function. Here I am using some function. That's the only thing. So we studied arrays, we studied functions. So we must study how to use arrays in function. So for that only I have done this example. So anyway, in the next class we will do linear search using functions. At that time it will be more clear. Okay. Anyway, here one more statement is required. Printf enter marks of %d students, comma n. So it is for only for more understanding purpose. In percentage D, that n value will get printed. In that percentage D, that n value will get printed. I will execute the program. Again, I missed the semicolon. I'll execute the program. Suppose I'm entering 4. It will say enter marks of 4 students. So by seeing this, user will enter 4 marks. 7, 2. So those marks will be printed. Any other doubts? Any other doubts? Can we wind up today's session?